Solver is an advanced version of GoalSeek. It's an excellent tool for making choices between multiple investment options to maximize profit. For example, you can use it to help choose how much to produce of each product when you have multiple products, or choose which capital investments to do out of a list of multiple options. Solver is an add-in for Excel. Here are the steps to add it to your Excel. To access the add-ins, open Excel and click the File tab, then select Options from the menu. Click on Add-ins in the left-hand menu. In the Manage box, choose Excel Add-ins, click the Go button. In the Add-ins Available box, check the box next to Solver Add-in. Click OK to confirm and activate the Solver add-in. After activating the Solver add-in, you'll find the Solver command in the Analysis group on the Data tab. I'll walk through using Solver with this example dataset. In this example, I've left the continuing education course business and now serve CPAs by selling them custom dress shirts. You can have your customized shirt in any color you want as long as it's white. Also, I only sell 3 sizes of shirts: small, medium, and large. Here's a summary of the rows in this analysis. Row 3 is the demand for my shirts. This is the most I should make. Row 4 is the number of shirts I should make this month. We will be solving for these cells. For now, I've just put the demand amounts from row 3 into this row. Row 5 lists the number of hours it takes to make each shirt. I only have 5 employees, which totals 800 hours of potential labor. Column F shows this constraint. I don't sew shirts. After years in the corporate world, my skills have atrophied. I can now only manage people and am unable to produce anything of value. Row 6 lists the number of yards of cloth it takes to make each shirt. I only have 600 yards available to me this month. Column F shows this constraint. Row 7 is how much I sell each shirt for. Row 8 is the variable cost for each shirt. Row 9 is the unit contribution, which is the row 7 price minus the row 8 cost. And row 10 is the total contribution. This is row 4, which is number of shirts to make, multiplied by row 9, which is the unit contribution. You may have noticed that there's a problem with the numbers I put in row 4, the number of shirts to make. The total employee hours in row 5 and the total yards of cloth in row 6 both exceed my capacity constraints. I can't find anyone else to work for me, and no one wants to sell me more cloth. Thus, I must produce only the number of shirts that stay within these constraints. How many of each shirt should I make? It's time to unleash Solver to answer my dilemma. I select Solver from the Data tab. The Solver Parameters dialog box pops up. This is how I filled out the dialog box. The Set Objective box is like the GoalSeek Set Value box. The 2 radio buttons allow us minimum or maximum solution to the objective in addition to a set value. GoalSeek doesn't allow the max and min options. In this example, I want to maximize cell E10, which is the total contribution. The By Changing Variable Cells box is similar to GoalSeek, except that you can specify more than one cell to change. In this example, I'm changing the 3 cells that specify the number of each shirt to make. The Subject to Constraints section allows multiple constraints on achieving the objective. I mentioned these earlier. Here are the constraints for this example. The first 3 rows of constraints set the maximum number of each shirt to the demand for that size of shirt. The 4th row of constraints sets the maximum total labor to my constraint of 800 hours. The 5th row of constraints sets the maximum yards of fabric to my constraint of 600 yards. I set the Select a Solving Box method to Simplex LP since this is a linear problem. You can explore the Options button for this box if you want to become a pro at using Solver. There are many options to change. I then press my trembling finger on the Solve button at the top of the dialog box. In nanoseconds, Excel tells me the phrase that only analysts can truly appreciate: Solver has found a solution. This is in the top right corner of the dialog box here. I further bask in the sentences at the bottom of the dialog box that says, Solver has found a solution. All constraints and optionality conditions are satisfied. They are satisfied, and I am satisfied. My shirt production quandary is solved. If you get a message that says set values do not converge, your model has an error or can't be solved. You likely need to change your constraints or other variables to create a data set that can be solved. Before revealing the answers, let's look at the options in the results dialog box. I can keep Solver's solution or revert the number to my original numbers, and I can also save this as a scenario. Let's look at the results from Solver. Solver is telling me to make enough shirts to meet the demand for small and large sizes. I then make enough medium shirts until I reach my cloth capacity constraint. I still have some slack in labor hours. From here, I could do more modeling to optimize production. I could find out how many yards of cloth to buy next month so I can maximize my labor hours and contribution. I may rerun this with adjusted price and demand numbers. Some people may have looked at my data set and thought that the intuitive course of action was to maximize large shirts because they have the highest contribution, and then make small shirts and then the low margin medium shirts. This intuition doesn't factor in the consumption of my constraints. I lowered the cloth constraint to 300 yards to see what Solver recommends. Solver shows us that we want to fill the demand for small shirts before making the large shirts. The contribution of a small shirt is lower than that of a large shirt, but they use the constraints more efficiently for the contribution they provide. Of course, we probably wouldn't want to make just lots of small shirts and no large shirts. This wouldn't be good for customer satisfaction in the long run. I could amend the solver to add constraints for the minimum number of each shirt to make. An analysis junkie like me can spend hours going through solver, but we need to move on to other useful Excel functionality.